Welcome everyone to EC404 College. I am Shamim and today we are going to discuss about one-time pad algorithm. So in our previous lecture we discussed about Caesar cipher algorithm. If you watched that video and understand that properly, then this algorithm will be a piece of cake for you. One-time pad algorithm is the improvement of the Fermat cipher proposed by an Army Signal Corps officer, and it is the only available algorithm that is unbreakable or completely secure. So in order to understand this algorithm properly, we need to remember few key facts of this algorithm. The first one is the shift key of this algorithm should be the combination of alphabet. For example, our shift key can be something A, B, C, but it cannot be 1, 2, 3 like this. Okay, we cannot use number or something else. We only use shift key as a alphabet, something like word or sentence with alphabet, combination of alphabet. Okay, and the second key point is the key should be randomly generated as long as the size of the message. For example, our message is Shamim. Okay, the length of this message is 6. So if we say that our shift key is S or SB, suppose, okay, the length of our key is 2. So we need to generate a 6 length key. So how will we do that? First we will write SB, then we'll write as our third index is the first one here, S, then B comes here, then again S come here until it becomes 6. Okay, we just repeat the circular process and write down everything. Okay, so our 6th line shift key will be SB, SB, SB. Okay, so we need to remember these two facts. Okay, so in this algorithm our encryption and decryption process will be similar to Caesar cipher. First, in our encryption process, first we need to plain text as our message to our computer, then the computer will implement the encryption algorithm with the help of key value and it will generate our cipher text. Okay, and in your decryption process will give a ciphertext and our computer will implement a decryption algorithm with the help of shift key and it will generate our plain text. So in one-time pad algorithm, if you want to find the index value of ciphertext, then we just need to add the value of plain text index and the value of shift key index. Okay, and if we want to find the plain text index value, then we will just need to substitute the index value of shift key from the index value of ciphertext. So let's an example of encryption in this algorithm so we can understand it a more better way. Okay, for example, let's think our plain text as apple and our shift key as good. Okay, okay, so okay, let's write down the index value of plain text as A as 1, then P as 16, and L for 12 and E for 5. Okay, now here, so let's see, in here our length of our plain text is 5. Okay, it is 5, but in our shift key the length of shift key is 4. So how can we make it 5? Okay, the same as P. Okay, we just need to the write down our first index in last. Okay, so our length of shift key now become 5 as the length of our plain text. Okay, now we just need to write down the index value of shift key. For G we have 7, for O we have 15, for D we have 4, and for G again 7. Okay, Now we need to find the index value of ciphertext. So we previously discussed that the index value of ciphertext equal to this equation. Okay, this equation, we know that. Okay, so now we just add this 1 plus 8 7 equal to 8, 15 plus 16 equal to 31, 31, 16, and here we need to write down 12. Okay, so in our encryption process we have two conditions here. Okay, either the range of ciphertext should be between 1 to 26, this is process A, and it will be become ciphertext will become uh, greater than 26, this will be our process 2 or process B. So in this case it's in process A. So if it's in process A, we just need to write down the value of that index, okay, H, as our ciphertext. But if it become greater than 26, then we need to follow the process B. In process B, we just need to subtract this value 31, subtract 26 from our ciphertext index value. Okay, so the equation will be like this. Okay, okay, for here 8, we write down 8, and here we will write down ciphertext 31 minus 26 will be 5. Okay, for here it's also 5, and here we will write down 16, and here we will write down 12. Okay, now we just need to write down the value of those index. For 8 we have H, for 5 we have E, and for 16 we have P, and for 12 we have L. Okay, so for apple, for plain text apple, with the shift key as good, we will get a encrypted message which is ciphertext HEEPL. Okay, so this is our plain text, and this is our shift key, and our encrypted message which will be HEEPL. Okay, so now let's give you an example of decryption. We will decrypt this ciphertext, and if we found apple as our result with the shift key good, then our algorithm is a success. Okay, so let's write down our ciphertext as H E E P L. Okay, now we need to write down our key as good, but we have length 5 of our ciphertext here, so we need to make sure that our shift key value is also length 5. Okay, so we need to write down G here for make it length 5, and now we need to write down the index value of ciphertext and shift key. Okay, our ciphertext index value are 8, 5, 5, and 16, and for L we got 12. Okay, and for G we got 7, for O we got 15, 15, for D we got 4, and for G is 7. Okay, now we know the equation to find out the index value of plain text. Okay, so the equation was like this, ciphertext minus key. So let's do this. 8 minus 7 equal to 1, 5 minus 10 equal to minus 10, 15 equal to minus 10, then 5 minus 15 again is minus 10. From 16 minus 4 is 12, and for 12 minus 7 is 5. Okay. Now again, here we also have two process process A is the range of our uh, plain text index should contain the range 1 to 26, and for process B, the value of the plain text index should be less than 1. Less than 1. Okay. So here we got the value between 1 to 26 here for our first index. Then we just need to write down it. Okay. But in here we got the value -10, which is obviously less than 1. So in this case we just need to follow a simple addition. Okay. For the addition will be the plain text index value plus 26. Okay. So here if we add 26 to -10, we will get 16. Then here is also 16. For here 12. For 16 we got P, and for 12 we got L. For 5 we got E. Okay. Okay, so let's discuss about the code of our algorithm. So in our first line we just import the Dart input and output library here, and in our main function we take our message input from user, and then convert it into a array list. Then again we take input shift key from user, and then again convert that into also a list, and then we give a user choice whether he want to encrypt or decrypt the message. According to his choice we call encryption function or decryption function. So in our encryption function we check whether the length of the message is less than the shift key length or it is greater. If our shift key length is less than the message length, then we will create a loop where we make sure that the length of the shift key is equal to the length of our list string, which is our main message here, which is you can call it a plain text. So after that we just call the encryption process, where we pass the index value of our message sequentially and the index value of shift key sequentially also, and get a ASCII value from there, and then we print this ASCII value as our decrypted message. Okay, so in our encryption process we first check if the value we pass here, the message value, index value we pass here is either the ASCII value of space. So if we find space, then we just skip this and return space. We won't decrypt that message. Okay. So then as we discussed previously, we just need to find the ciphertext index. So we add our plain text index and shift key index, and then get our ciphertext index. Okay, then we check if the ciphertext index is between the range 1 to 26, which is the total number of alphabet. Okay, if it is between this range, we just return the ASCII value of ciphertext. Okay, same as it is. Okay, then same as it is, and then we again check if this condition becomes false, it's not in the range of 1 to 26, then we will check another condition, which is it greater than the number of total alphabet, which is 26. Okay, it is greater than 26. If it is greater than 26, then we just return the value where we subtract 26 from ciphertext. Okay, and this else part, it is not required. We just make sure that if we find something unexpected result, so we can return ASCII value of less than, like this. Okay, then in our decryption method we follow the similar pattern as our encryption. Okay, so in our decryption process we also check if it is a space or not. If it's a space, we just return the ASCII value of that space value. Okay, then we also know that the way we can get the index value of plain text is just by subtract shift key index value from ciphertext index. Okay, we just write it down. Now we check if the plain text index value we get, is it the between the range of 1 to 26. Sorry, it is 1. Is it between the range of 1 to 26? If it is, then we'll just return the plain text index value we get. Okay, and if it is not, then we check if it is the less than 1, which is a negative value, or 0. If it is, then we will just add 26 to our current plain text index value. Okay, and if our plain text index value is none of these two, then we will return that something is wrong. Okay, so it is not necessary.